Algebra 3, Chapter 2, Section 2, Functions. A relation is a set of points, x, y, that have some kind of correspondence or relationship. A function is a special relation. It's a relation where each x value is paired with only one y value. The independent variable refers to the x variable or the input variable, and then the dependent variable will be the y or the output variable. The reason for these terms is your input or your x, you decide what it can be. It can be anything you want it to within the confines of the domain that we'll talk about later. The dependent variable is determined after you have chosen a value for the x. So the dependent variable depends on the choice for x. The domain is the set of all x values. It's all of the input values, all the x values that you are permitted to use for the equation. And then the range is the set of all the y values, or the output. Now, when we represent a function, we can represent it verbally by a sentence that describes the relationship. We can represent it numerically. We can show it on a table or a chart or a list of numbers. We can also represent it graphically on a coordinate plane. And we can represent it algebraically through an equation that relates x and y together. In a function, every x value should result in only one y value. On a graph, we can check this using the vertical line test. Any vertical line drawn through the graph should touch the graph at most one time. Okay, for this example, you're going to determine whether each equation represents y as a function of x. Pause the recording, give this a try, and resume the recording to see how you did. Our first equation is not a function. The reason for that is that with the plus or minus out in front of the square root there, that means that every x value that we come up with is going to actually lead us to two y values, and we can't have that. Every x value can only match with one y value. Our second equation is a function because no matter what x is, you're only going to get one y value as a result. Okay, function notation. We've seen this before. Here's some examples. F of x equals 3x minus 5. G of x equals x squared minus 7x plus 2. H of x equals x cubed plus 4x. The letters f, g, and h name the function, and that makes it stand out from other functions we may be talking about. The x in parentheses indicates what our input variable is. It's really important to realize that we're not saying f times x and g times x and h times x. F of x, g of x, h of x are the names of the function. The only thing that x does is tell us what our variable is. Function names and variables may differ based on real-life applications of the functions. For example, instead of x as a variable, you may be using t to represent time. If we're doing a function that is talking about velocity, then it may be v of t, v standing for velocity and t standing for time. When you're evaluating a function, often your directions will look like this. G of x equals x plus 5, find g of 7. All you do is replace the x with the 7 and solve. So g of 7 equals 7 plus 5, which means g of 7 equals 12. And that is the answer. I'm not doing anything else with this. My solution is 12. Again, the g of 7, all that means is that I took the function named g and I replaced the x with a 7. In the past, I've had people try to go further with this and actually divide by the 7. Do not do that. G of 7 is the name of the function and the number we substituted for x. It is not an indicator of multiplication. The final answer to this is 12. Okay, now it's your turn. I want you to evaluate the function at each specified value for t, and then simplify. All right, pause the recording, give these a try, and resume the recording to see how you did. Okay, g of 2 just means to replace t with 2, and when we do that, we get a result of 15. G of t minus 2 is a little bit more complicated. You're going to replace t with that whole thing, t minus 2. Now, what that means is you're going to have to actually square t minus 2. So you don't see it here because this was done quickly. It skipped a lot of steps. But you're going to have to do 4 times t minus 2 times t minus 2. So you'll have 4 times t squared minus 4t plus 4. And then you'll distribute the minus 3 to the t minus 2. That'll give you minus 3t plus 6 and then plus 5. When you multiply that out and you combine like terms, you get 4t squared minus 19t plus 27. The last one, we're supposed to put in t. We're supposed to actually just leave it, g of t, so that's 4t squared minus 3t plus 5. And subtract from that g of 2, which we already found in part A, that's 15. And when we do that, we get 4t squared minus 3t minus 10. Notice that the last two, that B and C, are not the same answer. Those are different processes. Now try this one, very similar. This is your chance to try again. Pause the recording, give this a try, and resume the recording to check your answer. So f of 2 is going to be the absolute value of 2 over 2, which is 1. F of negative 2 is the absolute value of negative 2 over negative 2, which is negative 1. And then f of x minus 1 is the absolute value of x minus 1 over x minus 1. Now notice they broke it up. They put it into what's called piecewise notation. We'll learn more about that later. But what that's saying is that it's going to give you negative 1 for the answer if your x is negative, because that means the denominator will be negative. The numerator, because it's an absolute value, will always be positive. So the only thing that's going to make this negative is the denominator. So if your x is less than 1, which would make the denominator negative, then your answer is going to be negative 1. But if your x is greater than 1, that means that your denominator will be positive and the answer will be positive 1. All right, now what you're going to do is find all the real values for x such that f of x equals 0. Now, what you do is you take the equation, like for the first one, 15 minus 3x, and set that equal to 0 and solve. And you should be able to do this. So give the recording a pause, give it a try, and then resume the recording to check your answer. So for the first one, 15 minus 3x equals 0, which means 3x equals 15, so x is 5. And on the second one, we've got 3x minus 4 over 5 is 0, so 3x minus 4 is 0, which means x must be 4/3. Now you're going to find all of the values for x, which make f of x and g of x equal. Now again, you should be able to do this. You're just going to set x squared equal to x plus 2 and solve. It's going to be a quadratic, so think about what we've talked about when how you solve quadratic equations. Pause the recording, give it a try, and resume the recording to check your answer. So we have x squared equals x plus 2. Now, it's a quadratic. Anytime you have a power higher than 1, you must get everything equal to 0. So we subtract the x and the 2 from both sides and have x squared minus x minus 2 equals 0. The left-hand side will factor into x minus 2 times x plus 1, and then we set each parenthesis equal to 0 and solve, getting 2 and negative 1 for our solutions. Now, we've mentioned domain. How do we find the domain of a function? Well, sometimes it's spelled out explicitly. In other words, they'll say, hey, x needs to be whatever. Often, it's implied by the expression that defines the function. A fraction, if we have a fraction with an x in the denominator, that's going to limit our domain because we don't want to have a 0 denominator. So any number that you could put in for x that would cause that to happen cannot be in the domain. A radical will limit us to what will not give us an imaginary answer. So if you have an even root, you don't want a negative under that, and that's going to affect what x values you're allowed to use. A word problem can limit the domain. We don't measure real objects with negative numbers. So if we're trying to do a problem with measurement, then you're not going to let x go less than 0. You can't have a fractional number of people. So that's going to limit the types of numbers you can use. You also can't have a negative number of people. All right, so find the domain of these functions. Think about what we just talked about, what limits the domain and what doesn't. Give these a try. Pause the recording and resume when you're ready to check your answer. Okay, for f of x, it's a polynomial. We have no fractions with an x in the denominator. We have no roots, and it's not a word problem, so all real numbers will be the domain. G, on the other hand, is a root, and we do not want y minus 10 to be negative. So y minus 10 has to be greater than or equal to 0, which means y has to be greater than or equal to 10. So our domain is y greater than or equal to 10. Remember, it is okay to have a 0 underneath a root, just not in the denominator of a fraction. Now we've got a word problem because we love them so much. So let's try this. An open box of maximum volume is to be made from a square piece of material 24 centimeters on a side by cutting equal squares from the corners and turning up the sides. The table shows the volumes, V, in cubic centimeters of the box for various heights, x. Use the table to estimate the maximum volume. Then plot the points from the table above. Does the relation represent V as a function of x? And then we're going to write the function and determine its domain. Okay, I'm going to let you try this on your own. The first part you should definitely be able to do, actually the first two parts. So give the 3 parts a try, and then pause the recording while you're doing that. Resume the recording to check how you did. Okay, first of all, we're trying to figure out the maximum volume. All we need to do is look at the chart and see that the volume is at its greatest when it is 1024 and x is 4. So when x is 4, the volume is at its maximum of 1024. Part B, we graph it, and really we're looking to see if any points line up on top of each other, because that would make them not a function, and none of them do that. They pass the vertical line test, so V is a function of x. And then finally, the equation, remember that volume is length times width times height. We have a square piece of material that's 24 centimeters on each side. We're cutting out x on each side, so that means our box is going to be 24 minus 2x for the two sides, and then the height will be x. So that's where we're getting that formula. The domain is between 0 and 12. The reason for that is if our side is going to be 24 minus 2x, we don't want that to go below 0. So the most that x can be is 12, and actually it can't be 12, it needs to be less than 12. Also, x is a dimension of height, and so it needs to be larger than 0, or we don't have a box at all.